Hi, a company called Delta Printer asked me to review their Delta Go 3D printer, and I was like, yeah. I mean, between the million of us, I'm just a beginner when it comes to 3D printing. But whatever, man, I love 3D printers. They provide the printer and I'll give them an expert review. Here's the printer. Now they have lowered the price to $350, which is much more competitive. It's quite tiny and cute, and yet it seems quite rigid and solid. Is this expert enough? They said it can print even if you shake it or place it upside down, which is not recommended, but I'm gonna do it later anyways. I've had my ElectroBOOM Mini for a while now, which is also a beginner 3D printer. What I've learned 2 seconds ago is that this structure is called the Delta printer and that one is a Cartesian printer. Each has its own advantages and disadvantages, which I'll Google shortly. One question I had was why? I mean, a Cartesian printer sounds pretty straightforward. The printhead moves in X, Y, and Z directions, while in a Delta printer, the head swings around like this. So calculating the head position for every pixel sounds like a chore. Well, it's not a huge chore. These thingies, which are called carriages, only move in Z-axis. Imagine 3 spheres centered on these carriages with a radius equal to these arms. Now you just triangulate. 2 spheres intersect in one circle, and that circle intersecting with a third sphere results in 2 points in space. One of them is above the carriages, which is garbage, so you have the location of your head. A fast processor can calculate it fast. The great difference is that a Delta printer has fewer and lighter moving mechanical parts, and that means less mechanical backlash and slop. Well, it's not an apple-to-apple comparison, but for example in ElectroBOOM we have a moving bed in Y-axis with its motor. This whole big structure moves in Z-axis with 2 motors. The printhead moves in X-axis with a motor here, and this motor and gears feeds the filament into the hot head. ElectroBOOM is quite sturdy too, but every one of these heavy mechanical parts has a little bit of backlash, so you can't print too fast or it will shake too much and distort the model you're printing. I'll give away one of these printers to my patrons at patreon.com at the end of the video. Let's check its design. It has a very small and light hot head. Oh, it has some stop switches up there, which is for initial alignment. It's quite snug, I can't feel any backlash. And this is the power of parallelograms. See, the hot head always stays horizontal. Actually, while I was googling, I saw a review of this printer done by 3D Printer Nerd. In the printer he received, these arms were held by magnets which disconnected during printing and made a mess.
It was crazy.
They have updated the design since and moved to these traditional joints that are pretty solid. I guess somebody was thinking way outside the box a while back and used magnets. You know, box is where we are safe and protected.
Skip the drama straight
In a box. I see they have one fan that blows air around the hot head that also comes out here to cool down the filament. The filament has to cool down quick enough to hold its shape. Now let's see where all those motors are. 4 motors are needed, 3 to move the carriages in Z-axis and 1 to feed the filament. I was expecting to see smaller motors and a larger control board. It's nice to see they use the strong motors for a tiny printer. It also has an SD card reader that you can load your model into and print it without having to connect to a computer. Just don't accidentally plug it in above the connector like I did. And also this printer doesn't work without the SD card or connect to the computer, so don't lose it. Anyways, the lack of backlash and slop helps speed up the printing, but by no means that's the only factor. For example, other factors. This printer has a smaller nozzle size, which means more printing resolution, but also less material output, which could slow it down. Also, the smaller hot head means that it heats up quickly but also cools down quickly if you try to print too fast and push too much material in the head to melt. The drop in temperature solidifies the filament in the head and it jams and you can't print. To solve that problem, you typically raise the head temperature above normal so that when it drops, it still drops to a proper level. I'll try to print fast later and see what happens, but for now, let's print a large object with default parameters. I have to set it up first time. The first time setup is a bit of a manual work. I won't call this a plug and play. Fortunately, they provide step-by-step instructions in their website. It's just one time, so whatever. Now let's heat up the head and feed some material through. You see the LEDs start to get red as the head hits. Because the head is small, it heats up quite fast, so be careful. Something I also realize is that the printing area of a Delta printer is a circle rather than a square as in Cartesians. But the footprint of the Delta printer is smaller, so for the same printing area you use a smaller desk area. I've designed this simple pencil holder that pretty much covers the entire printing volume, which is 115mm in diameter by 127mm height. It's printing just fine. I should say its noise level is lower than the Lulzbot. Done, and it only took over 19 hours to print with default settings. I wanted to see the print quality before I mess with the settings too much. I kind of messed up a little bit too. See, the pad didn't stick to the bed well and resulted in some warpage. Because although they said I should clean the surfaces with isopropyl alcohol to make sure things stick together well, I didn't because I didn't have any. The material cools at different rates and this can cause warpage if surfaces are not holding to each other well. It's not too bad though. This kind of attention is what you need when you don't have a heated bed like this one and you want to print large surfaces. A heated bed makes sure that the material sticks to the bed well and keeps the temperature even on the bottom, so it's much less likely to warp. This is pretty much the entire printing volume you get from DeltaGo. Maybe you can get a little bit wider if you tweak the settings. I should say the print quality is pretty good, the surfaces are pretty smooth and all the layers are there. There is some fuzz in there that I can clean up easily. There, no more fuzz. Now I have dropped and broken my light fixture, so I designed this broken piece and want to print it. Okay, let's start printing. Now let's see. They did say I could shake the printer while it's printing, and in fact I should be able to print upside down too, I suppose. So let's just print upside down and see what happens. Well, good luck, printer. Well, I'll be. This printer can print upside down. Well, there is some funny business going on here. It seems like at some layer the 3D model is shifted, maybe a corrupted file or something, so I'll have to print again. Layers shifted again. Let's print right side up. There, now it's good. Shifting layers had something to do with printing upside down. Otherwise the printing quality is pretty good. I'm especially happy with the quality of these tiny holes. Let's replace the broken leg. Nice, it fits like a charm. There we go, like new. I think the reason the layers shift when I'm printing upside down is that the molten material kind of droops and the passing printer head hits those material, which causes head misalignment. So don't print upside down. Now I want to print Benchy the boat with a fast printing speed with a better filament color. With the original high resolution parameters I was using, Benchy takes around 2.5 hours to print, which is a decent speed. But now I'm going to change the layer height from 0.1mm to 0.15, double the printing speed to 60mm per second and raise the printing temperature to the maximum filament temperature. And that gives me around 1 hour 15 minutes. Let's print. It's running pretty nice and fast. Let's see if it's good all the way. El Danzo. Well, I would say to my beginner's eyes, it's a pretty acceptable fast printing quality. I mean, there are some fuzzes and imperfections here and there. In fact, let me clean it up a little bit. Yeah, it's not too bad for a fast print. See how well it handled those holes there? 3D printers usually have problem with small features like this guy back here, or overhangs like that one. There are some layer issues around here, or maybe some overhang problem there, but in general it's pretty clean, I would say. Well, again, maybe my standards are not as high as a professional printer. So in conclusion, I would say it's a decent printer overall with decent quality, suited for beginners at good price point. I would say the pros are small printer size, low noise, easy to use, low price, solid body. And the cons are, there is no heated bed, so warping can be an issue if you're not careful. Small printing area, a little bit harder first time setup. That's pretty much it. Like I said, decent beginner's printer.
Giveaway time!
As always, thanks for watching and supporting my channel. I only have one of these to give away to my patrons at patreon.com. And a word of advice, only print things for others that you don't mind them printing for you.